this is something that we have to try and deal with as a security community, because this is a really hard problem to solve. And the reason being is we kind of put these medical devices in the same category as IoT devices with security. And the usual go-to thing with IoT devices is to put them on their own wireless network where they're segregated from the rest of the network and segregated from all our special and secret data. Well, we can't necessarily do that because we need these devices to be on the same network as all the cool stuff so that the nurses can watch someone's heartbeat monitor and all that crazy stuff, and they can pull down patients' records and stuff like that onto these devices. So they had an interesting statistic about all the attacks in 2015. A survey of over the past 2 years, 81% of healthcare organizations were the victims of cyber threats and had their data compromised. That's huge. Think about it. Your medical information is being compromised, someone's stealing it, taking it from you, and putting it on the internet for their own gain. Think about that. If you've got a weird ailment, you don't want someone else to know that. Think about that. So, the big reasons is, as I say here, we have poor cyber threat monitoring, we have poor cyber security policies, and weak data access control. So we have just inadequate policies and rules to stop these things from happening. So the FDA, weirdly enough, is trying to put guidelines for a one-all policy to try and solve this problem. So this could be a good or a bad thing to try to move the industry in a way where, okay, if you make a medical device, it has to be secure. You have to meet these guidelines for it to be secure. You have to design it in a secure way so that we don't keep running into these problems. That's great, no. But here's the other problem that we run into. We can have all these fancy policies, but if you're a hospital with a multi-million-dollar machine, you can't just go out and buy a new one. So let me give you a little what I mean by that. There are multi-million-dollar machines that have software developed for Windows XP or 2000. And you can't upgrade Windows. You can't even change Windows. You have to run it on that specific version. So you have to run it on XP or Windows 2000. There are machines like that in hospitals. And they're multi-million-dollar machines. And if you have multiple million-dollar machines, what are you going to do? What are we going to do as security professionals? So this is something to think about moving forward, is that we have these devices on our networks. And we need to think of a way that how we're going to protect and secure them when we have these impossible situations where we can't necessarily buy a new piece of equipment so that we can update the computer that it runs on. Because we need to upload whatever images that we're taking of someone's body to the central server so that the doctor and the 8-4 can look at them. So even more on that note, ransomware is getting more targeted and it's getting really expensive. So this is Krebs on Security. For those of you who don't know him, Brian Krebs, awesome guy. He has this really awesome blog, but it's down right now. There's an awesome blog about why his website is down, but we're not going to go into that right now. But he's a really awesome guy. He's got a lot of contacts in the dark web. So when things happen, such as like the Home Depot attack and the Target attack and all that, he was one of the first people to know. He may not be the first person to post it, but when he does, he's one of the first people that posts it, and he usually has the full story with all the information, and most of the time it's always correct and it's the facts. So that's why I like him. He's always on his page. He doesn't put stuff until he's really sure that he's got the right stuff. So he goes into talking about ransomware and how it's become a really bad problem for things such as the healthcare industry, like we just discussed. But these people who were creating the ransomware usually just sold it to the highest bidder. If you wanted to buy it for an hour, they're like, sure, why not? Here you go. Just share it the love. If you were willing to pay, they gave it to you. Now they're going, well, we can make it more profitable for ourselves, and we can get some more out of it. So, where was it? Give me 1 second, I'll just text. I can't find it. Somewhere in this text, but I'll tell you anyway. Alright, so somewhere in this text they said they're going to make the ransomware more targeted to things such as banking, specifically, the top one. Health companies, because like what we just discussed, law firms, and architecture places where we store information that's really sensitive to our everyday lives. So we need to start thinking about this ransomware is something we need to start thinking about, because this is a way for attackers not just to cause your life havoc, but to make your life a living hell, and at the same time make money. And that's what it's all about. So, there's this really cool tool that I found this week. It's a GitHub open source. So, does everyone know like how we have like a big problem with web browsers and exploits and blah 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 blah? We hear it every single week, right? Alright. So some of the things, there's like add-ons that we can do to make it more safe. But at the end of the day, nothing's really that good. So what they try to do is take a web browser, and when you click on it, I'll show you in the video, they take the web browser and they boot up a virtual machine and run your browser in a virtual machine. So I'm going to show you a quick video of that right now. Somebody's running I don't care about your key yet. Alright. So we booted up the web browser from down here. This is actual a virtual machine right now with the browser's running. So why do you want to run your browser in a virtual machine? Because it's a separate kernel from your actual operating system. So if there's actually a website that you go to, it only affects your VM, not your actual host operating system. So that's what's really cool about this. And we're starting to see sandboxing starting to move towards techniques like this.
So is this basically just an extension of what Docker does, like for like common applications instead of like servers?
They use a software called virtual VMs type stuff. So I encourage you all to go play with it. It's open source. It's really cool. So I was playing with it.
So Firefox actually had a vulnerability where if it was caught in man-in-the-middle attacks, and an attacker was able to replace the certificate for one of Mozilla's like certificates. It was add-on.mozilla.com. Add-on.mozilla.com. They could, with a forged certificate, Firefox wasn't actually validating the certificate pinning properly, and you could actually shovel code into Firefox and have it execute. Certificate pinning is where you say on the browser side, okay, I've been to this site before, so I'm only ever going to accept this certificate from there. So a lot of browsers nowadays, like Chrome, Firefox, they have a whole bunch of like common websites. Their certificates are pinned down. So like they have a certificate for Google, and they say, okay, this is the public certificate for Google. We're only going to accept this certificate unless an official like revocation of that certificate is submitted by that certificate. It's a certificate a lot. But essentially, the browser wasn't validating that properly, and because of that, there was a local execution exploit. This did affect both the most up-to-date version of Firefox. I think the patch was released on the 20th, which was 3 days ago. If I can read that, these numbers correctly. But it also did affect the Tor browser, because the Tor browser is based off of Mozilla Firefox.
So one thing to keep in mind for those of you who are a little confused, certificates are used to prove authenticity of who you're connecting to. So how do we know that we're connecting to Google.com? Well, we have the certificate that's from Google.com, and then we have a third-party So TLDR, it depends. It's hard. We can't tell you what employers are going to ask, but we can try and help you give you a couple general ones that we've heard that are asked almost all the time. So the TCP handshake, we covered that week too. The difference between encoding and hashing encryption. Is that last week? What is Heartbleed? That's something you'll have to search up on your own. That's a vulnerability that came out in 2013. How does MSO 867 work? The common exploit that we're going to get to in 3 weeks when we do Windows. And the process of how to get to Google through going through requesting the DNS process to get the IP of Google, and then through the TCP handshake, and then the HTTP. So.
That question is actually a really fun question if you learned it, because you start at like the top of the stack on one machine, you go all the way from the browser down to like the ARP cache on that machine, and getting off your network, and routing to that destination network and such, resolving DNS. It's actually a really like fun conversation when once you understand all that. It's really cool to go into it. And one of the biggest things, like I would say in my interviews, that has like gotten me the farthest and like the most respect is saying I don't know. Like, if you're on a phone interview and someone asks you a technical question and you freeze up, don't Google it, okay? Tell them what you do know. Don't try and fake like you know it. Admit that you don't know and say that you're interested in it and ask them to explain it to you. Because people are looking more for someone who wants to learn than someone who's a know-it-all that's just going to come in and do their work and go home and collect a paycheck.
So let's be honest, who's scared of career fair? It's intimidating. I'm still intimidated by it, even though. So the thing is to remember, so it's okay to say you don't know, because an interview is going to be a series of questions. They're just going to keep asking you until you say you don't know. And that's okay. They just want to see how far you're going to get, and that's how they're going to evaluate you. So at some point you're going to say I don't know, or they're just going to keep going until the end of time. So, all right. So the RC3CTF, as we all know, it's starting Friday, November 18th, and it's going to go until Sunday, November 20th. It's going to stop at midnight. So everyone has a chance to win prizes, no more than 5 per team. If you want to win prizes, go away, firewall. No. And if you want to win prizes, no alumni. RC4, definitely sign up. We're going to pair you up with an upperclassman, and underclassmen and upperclassmen are going to get together. You're going to do a really cool project. Saying you don't know anything is not an excuse. That's the cool thing. You get to learn something new and you get to show someone else. I talked to a couple people who told me they wanted to do this, and I was like, wow, that's freaking cool. I have no idea what that is, but I want you to teach me. You can teach me something as a first year to a fourth year. There's always something I don't know, and there's always something we can teach each other. So sign up. It doesn't matter how simple it be. It can be 5 minutes long. As long as you're sharing information with the rest of the group that you think is cool, someone else will too. So sign up. Alright, so we have a blue team competition at the University of Buffalo. RC3 is definitely going to go, so that's going to be Saturday, November 19th. So if you want to do that, talk to Kyle Coretto. As the date gets closer, we'll have more information, but just kind of keep that on your calendar if that's something you really want to do. It was a really great event. So, Daryl Johnson, did you want to talk about Skater real quick and project?
For those who don't know me, I'm Daryl Johnson, professor. I'm working on a proposal with some other faculty on a SCADA project that will take to Imagine RIT. Everybody knows about Imagine RIT, right? The big get together in here. For those who don't know about SCADA, SCADA is all of that equipment. You also hear it by the name of industrial control systems, cyber physical systems, Internet of Things, lots of terms like that refer to it. SCADA is all that infrastructure that controls things that move, that controls things that push fluids around, that control the distribution of electricity, power, water, traffic, it's all that kind of stuff. So it's all the things that are kind of under the table, controlling all the things that we see in the world around us nowadays. The goal of this project is to develop an event for our Imagine RIT that encompasses 2 components. One, something that will illustrate to the public just how pervasive this infrastructure is, how it touches their lives, and why they should be interested and concerned about it. The other part of it, we hope, is to turn it into a mini competition for looking at and illustrating the insecurities of most SCADA systems and the effect that having poor security on the SCADA systems can do to the things that you depend on day in and day out, like water, being able to pick up your telephone, getting to Netflix. Well, okay, that's not really that concerning, but so there's two parts to it. This event that we're going to do a mini competition and building something that will help illustrate for the public what this thing is. To put it in perspective, I try to illustrate the SCADA environment as kind of like blood pressure. Okay, everybody has it, you got to have it to live, but you don't know about it. And high blood pressure is something you can't feel. It's not like a cut or a bruise or a knock on the head to tell you something's wrong. High blood pressure, unless you actually look for it and try to test for it, will all of a sudden just keel over and you're dead. It's the silent killer. That's where SCADA is, unfortunately, in our environment right now. It's the silent killer. You don't know about all the things that are going on around you right now. Keeping the lights on, keeping the temperature constant, making sure that the toilet's flush and that the water fountains have water, and all those other things that we depend on. You don't know about them. You don't see them, you don't hear them until they fail. Okay? If this is something you're interested in, I want the faculty that are involved in this want to put a cadre of students together to help work on building a model city or something of that ilk, help illustrate this issue, and then assembling the competition around that. If you're interested, please send me an email. Please make the beginning of your subject the capital letter SCADA so I can pull it out of my big mailbox. And I'll put you into a list and try and keep you informed as this project goes forward. And if we get a group of people to put it together and get it funded, hopefully we'll have an interesting project to work on. Okay? Any questions? All right. Thank you very much. Thank you very much.
One more quick announcement. So Jamie was here a couple weeks ago. He was from Grim, the people that are offering the thing to SchmooCon, and also people who make the top scores on our leaderboards, jobs and stuff like that. So Grim will be here doing interviews in the fall. They'll have 2 weekends that they're here. It'll be Breakout Weekend, which is Friday, October 15th, and the weekend after Thanksgiving. So that'll be the full week after we come back from Thanksgiving. So it'll be Friday, December 2nd through Sunday, December 4th. That'll be Jamie who's here. They're only looking for juniors at this time. So he'll be interviewing with you guys, and then you guys will actually get your answer of whether they want to take you on for a summer co-op by December 10th. So if you have any questions, please contact Jamie Geiger. He's Lumbo in the Slack, or jamie@grimco.com. All right. So we're going to have an intro into the CFFA. It's CFFA stands for the Computer Fraud Abuse Act. This is our professor, Josephine Wolf. She's our cybersecurity policy and law professor here. You'll have her probably your 3rd year. I thought this was
something to look
important.
forward to.
Yeah. So I thought it was important to bring her in and kind of talk about the CFFA because we're teaching you guys malicious things, especially in the next coming weeks. And I want you guys to understand what you can and can't do and where is that legal boundary. So she's here to kind of help you guys understand, but she's not your legal counsel. Understand that?
Important disclaimer.
Yeah.
All right, so I'm going to talk very quickly for 5 minutes about the Computer Fraud and Abuse Act, which is the primary anti-hacking statute in the United States. Those of you who have taken my class have heard me talk about this for hours. You're not going to hear that again today. I'm going to do a very rapid overview of what this law means, what different people think it means, why nobody has any clue what it really means, and where things stand right now. Computer Fraud and Abuse Act, next slide, basically outlaws generally, basically says that it's illegal to access computers without authorization or in excess of your authorization. Who here thinks they basically understand what that means? Okay, you're all totally wrong. Nobody understands what that means. This is Robert Morris. He's the first person who's convicted under the CFAA back in the late 1980s, early 1990s. He's a graduate student at Cornell at the time, studying computer science. He started his graduate program. He's excited. He's smart. He looks around at this emerging internet. It's 1988. There aren't a lot of machines on it. He's like, seems like there's some security vulnerabilities in this email program, this directory software. I bet I could take advantage of those to spread a little program between computers on this network, just exploiting those vulnerabilities. He does. He releases what's called the Morris worm. It's one of the first worms ever. At the time, he releases it from a computer at MIT. Ends up spreading pretty widely on the, again, it's a fairly small internet at the time, crashes a lot of machines, causes a certain amount of damage. Prosecutors bring charges against him under the Computer Fraud and Abuse Act. This was unauthorized access. He says, no. I'm a student. I had authorization to use the computers at Cornell, at MIT, at Berkeley. That was all totally allowed. This is fine. And the court rules against him. First a jury rules against him, then a court rules against him, upholding the jury sentence. They say, this was unauthorized. Why? Somebody who's taking my class. Tell me why Morris's access was unauthorized. Yes?
We had access to the servers, we didn't have access to it in a way that used it.
Exactly. The court says it would be a better place without you, but there are pretty strong freedom of speech protections in this country. Not totally clear what charges can be brought against her. So the prosecutors go back to that language in the Computer Fraud and Abuse Act, and they say this was unauthorized. This was unauthorized use of MySpace. Not because she was using MySpace not for its intended function, because the intended function of MySpace is pretty much to create, or was pretty much to create profiles and send message connection. Says we can't say that all violations of terms of service agreements are violations of the CFAA, because then everybody would be a criminal. Goes all the way up to the Ninth Circuit Court, which is the top court on the West Coast, encompasses all of California and several of the bordering states. And the Ninth Circuit overturns his conviction. And they say, no, that's not basically a social, all of them so far stalled in committee, mostly thanks to the advocacy of Oracle. Do security research, if you do security work of any kind, even if you restrict this just to the most technical kinds of circumvention, it's still very problematic for a lot of people. What Morris did, finding vulnerabilities in common software programs, testing them out, is very similar to the kinds of things that many of you will identify if you go into the security field and look for vulnerabilities in code. There's a lot of legal uncertainty. When possible, you want to do that for the code belonging to companies and people who you think are not overly litigious and do not hate security researchers. I would very, very strongly discourage you, say, from looking for vulnerabilities in Oracle's code. There was a third thing I wanted to flag for you.
methods, forensics processes, etc. To which I then moved on into a different role where I became the security researcher and with the primary function of developing out the threat intelligence program. Now, threat intelligence gets thrown around a lot. A lot of people see it as a sexy buzzword that doesn't really have a meaning. So I'll attempt to describe and explain to you what threat intelligence is based off of my responsibilities. So, for example, you guys mentioned the equation here, right? Which is, TLDR NSA. The link of their tools is relevant to threat intelligence. So they are exposing their tactics, their methods, and their procedures, right? In threat intel, we call it TTPs, tactics, techniques, and procedures, or the modus operandi of an adversary. Dissecting their threats, their kill chains, doing a red team analysis against how they operate, and then applying that to your own organization is a means and method of threat intelligence. Basically, the NSA pops companies and governments using this kill chain. Well, does that kill chain apply to us? If so, would it work? Would we alert on it? Would we detect, etc.? Now, take a different example. A breach that happened to an industry here. Let's say LinkedIn got popped once, twice, who knows at this point, right? What are the details around that breach? Who attacked them? How did they attack them? What tools did they use? Where did they come from, etc.? And you gather all this intelligence, all this information, and then you apply it internally. Does this affect me? Does this impact me? And that's a significant portion of my job, is to understand what's going on in the industry, who's being breached, how are they being breached, and seeing if we can take their unfortunate doings of a breach and applying it to us to be more proactive. Analysis is a significant portion of it. Signature development is another. Developing signatures using Yara is a big part of my job. Developing Yara rules for certain binaries or malware payloads that are used by known adversaries, and then distributing that, not only throughout the company, but sharing it with other people in the industry. We may have competitors, but we don't want our competitors to be breached, right? Because if anybody's going after them, you can be sure as hell eventually they'll go after us. Another portion of my job is, so I work for bots, right? A lot of people like to abuse our platform, whether to, upload and distribute malware using it, or use our platform to target other people for sophisticated attacks. Now, doing an analysis on the account activity, where they're coming from, how they're interacting with the application, etc., and mapping all that out with a tool called IPtables is a significant portion of my job as well. Basically, linking accounts based off of behavior and activity, whether it be the upload of a file coming from a certain web browser, IP, user agent, etc. And finally, a big portion of my job is attribution. In incident response and security and threat intelligence, what is a big question? Why a big question? But more importantly, and the hardest question to answer is who, right? Who is going after you? Because if you can answer the who, then it helps you determine what they might potentially go after next. Rather than being 10 steps behind, you can be 1 step back or 2 steps ahead. So that's what I do day to day, and you guys are more than welcome to reach out to me should you have any questions. Ben can put you in touch with me. But before I wrap that up, I saw you guys mention the career fair. I actively recruit from RIT. I go to the career fair from time to time. And 2 tips from my end. Nick mentioned that if you don't know the answer to something, mention that, and that's excellent advice. Don't bullshit. Don't ever bullshit. That will be frowned upon. However, if you don't know the answer to something, if I ask you how does this certain Metasploit payload work, and you say you don't know, follow that up with, well, I don't know, but this is how I would find out. Essentially, you're showing them these are the types of resources I would go after. Here's my critical thinking
get back into the system and they've locked it all up, you're done. 2 is wrong and 1 is not. Some of the different types of persistence you do is writing your own malware, using malware that's out on the internet, and then implanting it on the system, having it call back to your machine so you can show it commands. Creating a backdoor, right? So let's say leaving SSH open on a certain port, creating a different user. So let's say I made a user called FTP underscore data. It's not a user you normally see on a system, but it looks kind of like it should be there, right? Things that look like it would be there. You also can do this by starting services. So let's say I have a malware I want to run as a service, or if you were to start up a service like SSH, or if you were to start up a web service and have a web shell in it that you can use to execute commands to the machine. And then modifying the firewalls. And IPtables is firewall software, so we'll get into that in a little bit. So when you sit down in a competition, you want to make something called a 5-minute plan. In reality, it's not going to be 5 minutes. You're going to get sidetracked. It's going to take a lot longer, but it's a good plan to have a 5-minute plan. It's basically what you want to do in the beginning to make sure that you're in a really good position. Some of the things is change your password. What you can do is you can flicker the NIC, which is drop it down and then turn it back on. That will kill all the connections that are on it. In most competitions, they want to make sure that your machine can actually be reachable, so this might be against the rules, but sometimes they won't notice like a little bit of latency. You also want to look at the connections that are on the box. If you're seeing a lot of connections going out to a subnet that you've never seen before in competition, that's probably something where red team is connecting, or it could be white team for scoring. You definitely want to set up a firewall to make sure you only access the applications that need to be accessed to the machine, and then look through your users' processes and just basically search for people on the box. So, changing your password on a Linux machine. There's 2 main ways to do it. One is the password command, which you're probably very used to. Just the password and then the username that you want to do. You can change the password for that. There's also a CH password, and what you do is you shovel in a whole new line separated file of usernames and accounts, and you use a end of file or control D to stop. So you can just say echo user pass and put a CH password, and it'll change the password for that. If you're given the root account, try and make a new user and then give that user pseudo privileges so that you have another user if you lose access to the root account. If red team blocks you out of root, you have somewhere else to do your work. It goes back to the whole 2 is 1 and 1 is not. So in order to flicker the NIC, what you can do is you can request a new address from DHCP if the environment is configured for DHCP. Just do a simple DH client for DHCP client -release, and then DH client again, get a new one. Or you can just do if down, interface name, if up, interface name, just drop it and bring it back up real quick. Once again, you want to change your passwords throughout in case someone has installed a keylogger on your machines. Oftentimes you'll see binaries on the machines that capture keystrokes and then send it off to you. So in that stat, you can display network statistics for all your connections on the machine. One of the common commands is ptuna or toltna or tuna LP. You can arrange the letters however you want. A shows all the connections, T shows TCP, U for UDP, N disables reverse DNS lookup so it doesn't go out and try and find a DNS name that's associated with an IP address. L shows listening, and then P will show the process ID so you can see what it is, and if you need to kill it, you can go and just kill it. So your users, all the usernames can be found in Etsy password. They're all there. RT-Kit, by the way, is not a malicious user. One person, it stands for real-time kit, which has something to do with the GUI. If you're a GUI user, a lot of things break. You can actually lock user accounts. So if you have a whole bunch of users on your machine in a competition, you know you're never going to use all of them, you can lock them in some view. So there's cases where white team will pick a random user to test your service to see if it's scoring. So if they're doing SSH, they might try and log in with Bob, or they might try and log in with Alice, right? If you see like Bob, Alice, Mallory, like 17 different accounts, if you go into Etsy password and replace the little X that's there in the second field with an exclamation point or a star, it'll disable the user. So you still have the user, and all you have to do is go back into the file and then then change it back to an X to say, okay, in Etsy's shadow, there's a password hash and you should check there. But if you replace it with that, you still have the user account in case you need to turn it back on again for what's here. Yes, also users with no password are bad because they don't need a password to log in. If you go into your Etsy shadow file, what's going on?
Yeah.
Okay.
Student office, not calling question marks.
Oh gosh. Yeah. Okay. So another thing that goes along with users is your groups. Each user is part of a group in a Linux machine. And a group is obviously the highest level. Anyone who's in each group has permissions of group, right? So if you look at Etsy groups, there shouldn't be anything after a group, right? There shouldn't be anything there. If you see things here, that's bad. You should probably remove them from that. If you want to edit pseudo privileges, so the ability to escalate privileges for certain commands, you can use a command called vi sudo, which edits the file in Etsy sewers. Don't edit that file manually because it can break things. So, you're on the system, and you've been there for a while, and you think everything's going okay, but there might be a callback somewhere, right? You might have a piece of malware on your machine that's calling back to Etsy. What you can do is you can use the command psaux, which displays remote connections, processes that have remote connections, and the PID, and what you can do is monitor them that way. It's like something, if netcat is running and it's not supposed to be running, you can audit that and say it is to be running. DW commands will show you who is logged in where, so you can look here and say, okay, I'm on GTY1. There's another person logged in from root from this IP address. Should that be there or should it not? Then you can change your firewall rules or kill that PTS. So, common places you want to look. In your home directory, there's a .ssh folder that contains all the configuration for SSH. There are things called SSH keys, which allow for no password login to machines via SSH. All an attacker really needs to do is if they get access, they can drop a key into the account, and then it's really easy for them to strip the login. /Etsy, that's where a bunch of configuration information is held. A lot of, actually, pretty much every service has their configuration file stored in Etsy somewhere. So it's either in a directory with subfolders in it, or it's just a file in there. /temp is really readable and writable. People will often use that for downloading malware or something, or putting in malware that they're going to run. It's an easy place that everybody has access to no matter what. If you haven't seen your path, then that's kind of bad. You should fix that. So, bash, that lovely shell that you're all used to using. You can configure it to do a lot of awesome stuff. You can configure it to do a lot of stupid stuff. In your home directory, you'll see files such as .bashrc, .profile, .bash_profile, and you can set aliases for commands. So if I wanted to change my ls so that it always listed all files, I can set an alias for ls to be ls-a instead. You can also create custom functions, you can set environment variables, do a lot of fun stuff. /etsy_skele is the default. It stands for skeleton, so you have like a skeleton file, and then each user's files for those mimic that immediately. And then /Etsy profiles uses that system-wide environment variables for all the users. So there's this awesome thing called cron, right? Cron allows you to do a task at a certain time. You can say, I want to run this command every day. Maybe it's a backup that you run. But you can also do things like dropping all the firewalls that are on the machine. You can also do something like scheduling a callback. To access cron, you need to use the cron tab command, and you use the -e flag to edit the cron tab. There are multiple different cron tabs. Each user has their own cron tab, and then there's also hourly, daily, and monthly. The format of this down here, they have a little M, H, and then the date of the month, and then the month, and then the date of the week. So you can set those like every week I want to do this. If you see all stars, it's going to do something every minute. If you see something like a 5 there in the minutes, so every 5 minutes this is going to call out the netcat shell. So aliases, I spoke about them before. Basically, it's saying you can make one thing, you mean something else, right? So if I want to say, if I want to change who am I, the command that shows who you are, to actually say, I'm actually using that command. And down there you'll see that this person isn't allowed to use ls. They're just told that they are a great kitty. So there's all this information that you guys have been looking at now. You're doing all these things. And connections, when you do like netstat, they only show up once, right? That's not really a live reflection of what's going on. To fix that, you can use something called a watch command. And the watch command will re-execute a command every time interval. So you can say watch-nw. That will be every 3 seconds. I want you to use the W command to show me who's logged into what TTY or PTS. You can also do the same thing with netstat, and then type the output for established connections to see, okay, who's connected to this machine. That's bad. Let's see what process it is. Okay, let's audit that, figure out where it's coming from, and then kill it. So overall, don't panic. You want to respond to something, don't react. Don't just play whack-a-mole with processes. Oh, wow, this is bad, I'm gonna kill it. This is bad, I'm gonna kill it. This is bad, I'm gonna kill it. Those all might be subsidiary processes to something that actually causes a problem. Check the bottom files. Sometimes people like to put a ton of white space, like 15,000 white space characters, and then put like their nasty thing at the end. Look for new SSH keys. If there's an SSH key in there that shouldn't be in there, and that you didn't put in there, you should probably get rid of it. Nmap yourself. Look at what services your machine is actually running. Just pro tip, don't nmap the loopback interface because things get wacky. Just do it with like the actual IP address. There's this awesome thing called PAN, which reserves this presentation in its own right. Basically, it's pluggable authentication models, and you can say, I want to authenticate this service in this way. They can be messed with to say, put a smiley face in instead of the password, and then that will allow you access. You really want to know what's normal and what's not normal. If you start killing things, that, like if you start killing GNOME on a Linux machine and GNOME is your desktop environment, you're going to lose that and think things are going really bad. Oh my gosh. Where to go? Who lost here? Okay. It takes time to figure out what's normal. If you're going to a competition, just prep. If you're going to be a Linux guy, look at Linux, set up a machine, figure out what's normal so you don't kill things that you're actually relying on. So we have our machine, right? We want to make sure nothing gets in. We've done our initial lockout. We've audited our users and such. We want to make sure that nobody talks to any other services that are running on the machine. So if your machine is only supposed to be running SSH and a web server, you want to make sure that people can only talk to the SSH server and the web server. And you can do this by using the whole firewall, which you're probably all very familiar with, but not with IPtables, which is the Linux firewall. IPtables is kind of like the root of the firewall and like the most common historic command. The way we have it set up is that there's the Linux kernel right here, and underneath it there are kernel modules that handle whether it's going to accept or drop a packet. And then you have the IPtables command. The commands UFW and GUFW have been built on top of IPtables to help it work more efficiently, but they vary from system to system. For example, UFW is Ubuntu, and then Firewall D is on CentOS. But if you know IPtables, you know essentially what they're doing on the back end, which means you can just write them yourself. So, what is IPtables? It's a host-based firewall, and it's based off of direction. So there are these things called chains, right? You have an input chain, you have an output chain, you have a forward chain. So packets that are coming in will go in the input chain. You can write rules on that. Packets that are going out from your machine will be going to the output chain and do things from there. The forward chain is used for forwarding traffic. You can create as many chains as you want, create some pretty complex rules. Use the basics that really the only ones you really need. So, a few common flags. The -L will list all the firewall rules that you currently have. -A allows you to append a rule that requires some other parameters that go along with it. -I puts a rule at a certain point in the firewall list. -D will delete it. -P creates a policy, so you can say, okay, by default on input, I want to drop all packets. I want to drop everything. I'm going to say, okay, I'm going to allow this, or I'm going to allow this. You can also flip that and say, I want to accept going the other way, more power to you. And then IPtables-F will flush all of the rules that are on all of the chains. So that's the way to clear it. So if you see IPtables-F, that is clearing all the rules that you have every node for rules. So basic syntax. So when you specify the chain, you specify all the parameters that go along with it. You specify that you're going to add a rule, you have to configure an action, right? You can either accept it, let it back through, reject it. You can drop it, which just says, I'm going to drop it, I don't care. I'm not going to tell them that they're not accessed. I'm just not going to say anything. I don't care about it. And then you can also tell it to log, right? So if you just want to have some